What if the next person to serve you coffee isn't human and was never meant to be? That question sounds shocking, but in the United States today, it's quickly becoming reality. Across the country, restaurants struggle with labor shortages. Hospitals face burnout at every level. Warehouses race against impossible delivery expectations, and businesses are under pressure to do more with fewer people. At the same time, service robots are quietly moving from novelty to necessity. They deliver meals, clean public spaces, transport medical supplies, and guide customers through stores. Yet what most people never stop to consider is this: these robots don't magically appear. Each one is the result of countless decisions about technology design and human behavior. That leads us to the core question of this video. How do service robots go from a simple idea to a real machine working alongside humans? Every service robot begins not with technology, but with a human problem. Designers don't start by asking what kind of robot they want to build. They ask what task is repetitive, exhausting, dangerous, or inefficient for people. A hotel manager notices staff spending hours delivering towels room to room. A hospital administrator realizes nurses are walking miles each shift, just moving supplies. A fast food chain can't staff late-night shifts consistently. These frustrations become the foundation of robot design. For example, delivery robots on American college campuses didn't start as futuristic experiments. They began as a simple response to students wanting food faster and restaurants needing reliable delivery without adding staff. The robot exists not to replace personality or hospitality, but to remove friction from the system. Once the task is defined, the next challenge is physical design. What should the robot look like? This decision is far more complex than it seems. A robot cleaning an airport terminal needs to appear durable and industrial, while a robot assisting elderly patients must. In the US, companies quickly learned that appearance affects trust. Robots that looked too human made people uncomfortable, while overly mechanical designs made users hesitant to interact. Designers now aim for a careful balance. Height determines whether people feel intimidated. Speed affects perceived safety. Shape influences whether people step aside or block its path. The robot's body becomes a form of communication, silently telling humans how to treat it. After the body comes the brain. Integrating robotics into the workplace demands a new approach to safety. The system dynamically adjusts the buffer zone, ensuring seamless cooperation. Cameras, lidar, microphones, and pressure sensors help it map spaces and detect obstacles. But robots don't understand the world the way humans do. They calculate probabilities. When a delivery robot navigates a busy sidewalk in a U.S. city, it constantly predicts whether an object will move. As the city evolves, so too must have its navigation protocols, constantly seeking the most efficient path. Designers spend months testing these decisions in simulations, but the real world always introduces chaos. This is why service robots improve. Slowly and cautiously, mistakes in public spaces carry real consequences. And that's where most robots fail real-world testing. A robot might perform flawlessly in a lab, then struggle on day one in a grocery store because of reflective floor. In American hospitals, airports, and retail stores, engineers closely observe how people interact with robots. Do they ignore them, try to help them, get angry when the robot pauses or makes a mistake? One surprising discovery is that people judge robots more harshly than humans. A small delay that would be forgiven from a person often feels unacceptable from a machine. As a result, service robots are held to higher standards, not lower ones. Here's the unexpected insight most people don't realize. The hardest part of designing service robots isn't the technology. It's humans. Robots don't usually fail because sensors are weak or software is broken. They fail because people don't trust them, don't understand them, or use them in ways designers never anticipated. Many robots are intentionally limited in what they can do, not because engineers lack ability, but because predictability makes humans feel safer. In many cases, robots are designed around human emotions more than pure efficiency. There are clear benefits to this shift. Service robots reduce physical strain, handle dangerous or monotonous tasks, and help essential services keep running. During labor shortages in hospitals, they can give nurses more time with patients. In logistics, they reduce injuries and increase consistency. But there are also real downsides. Jobs change or disappear. Smaller businesses may struggle to afford automation. Over-reliance on machines can create new vulnerabilities. When systems fail, designing service robots is not just a technical choice. It's an economic and ethical one. At the emotional core of this process is a deeper question. How do we value human time? If robots take over the most exhausting tasks, humans gain space for creativity, empathy, and connection. But if robots are designed only to cut costs, something essential is lost. The choices engineers and companies make today will shape how Americans work, heal, and interact for decades to come. So the next time you see a robot delivering food, cleaning a floor, or guiding visitors, don't just ask what it does. The prototype phase is critical. Every line, every curve you see here is a decision made with the future in mind. Do service robots represent progress, or are they a warning sign about the future of work? Are they freeing us or redefining us? Share your thoughts in the comments. And if this video helped you see service robots from a new perspective, consider liking it and subscribing for more stories about how technology quietly reshapes everyday life.